Hi guys, so we're back with another chapter for class 7. Okay, this time it's for physics and the name of the chapter is energy. So what is energy? Energy is the capacity to do work. Okay, we need to do some work. Okay, it can be anything. It can be just to walk from one end of the room to another end of the room. It can be just to pick up something. Okay, it can be to run around. It can be to walk to the town, come back. You know, we do a lot of work, and to do all of this work, you need energy. Okay, so what is energy? Energy is the capacity to do some work. So we've talked about energy is needed to do any kind of activity or work. Okay, like walking, running, jumping around, carrying something, pushing something, pulling something. Okay, anything. To do any of these things, you require energy. And what are the units of energy? There are two units of energy that we need to know about. First one is joule, second one is calorie. 1 joule is the amount of energy spent when you apply 1 Newton of force to move a body, okay, by 1 meter. To move a body by 1 meter, the amount of energy required, okay, is 1 joule. Our definition of calorie is the amount of energy required to increase the temperature of water by 1 degree Celsius. Okay, 1 calorie is the amount of energy required to increase the temperature of water by 1 degree Celsius, and 1 joule is the amount of energy required, or the amount of energy spent when you apply 1 Newton of force to move a body by 1 meter. Okay, so what are the values? Let's look at it. 1 calorie is equal to 4.2 joules. 1 kilocalorie, which is 1000 calories, is equal to 4200 joules. Please remember this. Okay, this value is important. 1 calorie is equal to 4.2 joules. When you have to change from joule to calorie, then you need to remember this. There are different forms of energy. Okay, so the first one is mechanical energy. It is the energy associated with either the motion or the position of an object. Mechanical energy is basically talking about energy of an object. Okay, in first case, whether the object is stationary. If it is stationary, then how much energy it has, and if the object is in motion, if it is moving, then how much energy it has. Okay, potential energy talks about the object which is stationary. Okay, the word potential itself explains what it means. It means how much energy an object can possibly produce. Okay, what's the potential? How much can it do? Okay, to understand potential energy, let's imagine there is a slope and there's a ball at the top of the slope. Okay, let's imagine there is a slope and there is a ball there. So, how much energy does this ball have? Okay, we determine it by the length of the height. Potential energy is the energy an object has. Okay, it's not spending that energy, but the energy it has. Okay, imagine a ball at the top of the slope. How much energy does it have? Okay, and imagine a ball on the floor. How much energy it has? Okay, the possible energy that it can produce future, that is potential energy. Okay, there are two types of potential energy, that is gravitational potential energy. Okay, that is defined by the placement of the object. If it further away from the surface, then it is high potential energy. If it is closer to the surface compared to the previous one, it will have low potential energy. Okay, so the height determines how much potential energy it has in the first case. In the second one, elastic potential energy, you can understand this by, so this can be understood by elastics, or rubber bands. A normal rubber band, when you pull it, okay, and you pull that, feel that tug, that is the energy that is stored out there. Okay, and when we release, the energy is released. Okay, this can also be seen in bow and arrow. When you pull the bow, okay, tight, so the energy is stored there. When you let go, the energy is released in the form of motion of the arrow as the arrow flies by. Okay, so potential energy is the energy of an object before it goes in motion, and when it is in motion, the energy that it has is kinetic energy. Okay, kinetic energy is the energy of objects in motion. Okay, we can understand more about this in other slides. Now let's look at, apart from mechanical energy, what are the other forms of energy? Okay, the other forms of energy are heat energy. It is the form of energy that gives us the sensation of hotness. Okay, it gives us warmth. Light energy makes things bright and helps us see things. Okay, it gives us the sensation of vision. Electrical energy, it is the form of energy created due to the existence of electric charges, and we will learn about this in detail in the chapter electricity and magnetism. So next is sound energy. Okay, it's the kind of energy that makes us hear things. Okay, it makes the possible vibration in objects, and that vibration is what we hear. Okay, it is a form of energy produced by the vibration of particles present in the object. We discussed that. Magnetic energy, again we will learn more about magnetic energy in electricity and magnetism, but let's just look at it. It is the energy possessed by or stored in a magnet or a magnetic material kept in the magnetic field of another magnet. And what is magnetic field? Magnetic field is the space around the magnet where we feel the presence of the magnet. Where we feel the repulsion and attraction. Chemical energy. It is the energy stored in substances. Okay. During chemical reactions, it is transformed into the other forms of energy, or vice versa. Chemical energy is basically what happens. Okay, in the previous chapter we talked about. That photosynthesis, right, and breaking down the food inside the body. Those are all chemical processes where energy is produced or consumed. So those are your chemical energy. Now, sources of energy. What are the sources of energy? There are two major sources of energy that we know about. Okay, one is renewable energy, another one is non-renewable sources of energy. Okay, renewable sources of energy are basically your natural sources of energy like sun, okay, solar energy, wind energy, hydro or tidal energy. Okay, solar energy, we know about the sun. We use it for photosynthesis. We don't use it, plants use it for photosynthesis, and we use nowadays for many things. Heating up the water. We use it for drying substances. We use it for batteries, solar powered batteries. Solar energy, there's so many things that we use it for. Solar panels. Wind energy, initially, we used to use it for windmills. Nowadays we use it for generating electricity. And tidal energy, we use it in dams to, again, to generate electricity, and in oceans we use the waves. Okay, those are tidal energy. We use the waves to create energy. Okay, we learn about these processes more in other classes. Next one is non-renewable sources of energy. These are the sources of energy which depletes. They are limited. Okay, renewable sources of energy are natural sources of energy. They are plenty in nature. Okay, we don't have the thing like, the sun is going to get over, or the wind is going to deplete. Okay, but non-renewable energy can deplete. They are limited. Okay, so what are those? They are like basically your fossil fuels like coal, petroleum, liquid petroleum gases. That's like LPG gas that we have, LPG cylinders that we have. Okay, these are your non-renewable sources of energy. Next, the energy chain. What it really means. In the previous chapter, we talked about autotrophs, heterotrophs, right? So autotrophs create food. Heterotrophs eat that. Eat, okay, or take the rely on autotrophs for food. Like for example, let's take it as animals. Okay, so plants make the food, animals eat the plants for energy. Okay, and animals they turn into fossil fuels. And where do the plants get the energy from? They get it from the sun. So from the sun, the energy goes to plant. Plants make the food, and animals consume plants for energy, and animals later turn into fossil fuel, and which we use it as sources of energy. Now, okay, so let's read this. Sun is the primary source of energy, and all the energy chains start with sun. Discuss that. Energy from the sun reaches the earth, undergoes a series of transformation, and is used by the living beings. Right? We need sun. It is our primary source of vitamin D. Right? It makes life possible. How? Sun gives us food. Sun is the reason we have food. It is very, very important. Next is law of conservation of energy. This is very important. You need to understand. What it means is the law of conservation of energy tells us that energy can neither be created nor be destroyed. It can only change from one form to another. Okay, like for example, you see there is a picture of a dam here, right? So what happens out here is the water is stored up here. Okay, so water goes up here and it comes down, goes there. First, when it goes up, there's increase in potential energy. Why? Because the height is increasing. Since the height is increasing, the potential energy is decreasing. And the potential energy goes down, changes into kinetic energy, moves down, makes the turbines spin. When the turbines are spinning, it is the kinetic energy, okay, of the water, okay, the flow of the water is turning into a mechanical energy of this generator. Okay, and this generator, this dynamo, is creating electricity which is going and is being stored. Okay, so we can see that there's a change of energy happening. Energy is changing from one form of to the other. It's not being destroyed. It's just being changed from one form to the other. Okay, so that is what it talks about. Law of conservation energy talks about energy which cannot be created and cannot be destroyed, but can only change forms. Okay, so here are some examples of these conversions of energy, okay, or change of forms of energy. So in electric bulb, electricity that is electrical energy is turning into light energy and heat energy. Light energy, we see it. Heat energy, we need to go and touch it. When you touch it, you'll see that the light bulbs heat up. Okay, they become very hot. That is because the electrical energy is being released, is changing the form, changing into light energy, which is making things bright, and heat energy, which is heating up the bulb. Electrical fan, okay, electrical energy is turning into mechanical energy. In solar cells, the solar energy is turning into electrical energy. In electric iron, geysers and immersion heaters, okay, these are the things we use to heat up the water. So what is happening is electrical energy is turning into heat energy. And here are the other stuff. I'll be providing this to you. You can go through this. As we've discussed till now, energy is very, very important to us. Okay, we cannot live without energy. We need energy to do some work. We need energy to do work, and we need energy for our daily activities. Imagine there was no electricity. Life would not be possible for us right now, because our life revolves around electricity. We need light, right? We need cell phones, we need computers, we need all of this, and none of this would be possible right now without electricity. If we didn't have electricity, our life right now would not be possible. You'd still be in dark places using candles. And can you imagine that? We can't. It would be boring. So we need energy. And since we need energy, we need to conserve energy. We need to save this energy. Okay? So how can we save energy? First one is, whenever possible, we use solar-based appliances. Okay? We use appliances which uses renewable source of energy, that is sun. This saves up electricity to a large extent. Okay? For example, solar cookers and solar lamps. We can use these to save up energy. Next one is, we can switch off lights, fans and any electrical appliances when we're not using them. Avoid overheating or overcooling while using water heaters or air conditioners respectively. Close the windows when the AC is switched on. Instead of using tube lights, compact fluorescent light, that is CFL or LED lamps, can be used to save electricity. When you have to travel short distances, avoid taking a car. Instead, just walk or take a bike. Walking is good for your health. Cycling is also good for your health. You'll burn your fat and you'll become less fat. Now let's talk about the relation between work and energy. Okay? We also know it as work energy principle. What it means is, or what it talks about is, work done is equal to K2 minus K1. Okay, that is kinetic energy, final kinetic energy minus the initial kinetic energy. Okay, so K2 that is half mv square v2 square minus half mv1 square. Okay, so I'm not writing it as m1 or m2. Why? Because the mass of an object doesn't change. Imagine there's a box, okay, which is sliding down a slope. The mass of the box, which was up there, is not going to change when it comes down there. Okay, it's going to be same. Mass doesn't change. Mass of the object doesn't change. What it changes the velocity. Okay, the speed changes. So since the speed changes, we are writing it as v2 and v1. So from here we can write half into m into v2 square minus. So this is your work energy relation. That's it for the chapter. Thank you for watching, and if you have any question, please contact me and you can ask me any question regarding this chapter